Before we start the instructions, we're going to go through the tools and supplies you will need to complete these instructions. First thing is a ruler. All of the units in this series will be in inches. A Sharpie is a good tool for marking the things we measure. And we'll need a Phillips head screwdriver and an X-Acto blade. We'll also want some masking tape. And I like to use a plastic bag or another drop cloth to keep my surface clean, so that doesn't hurt to help in clean up. We'll need drill bits, 3 different sizes and a drill to go with them. The sizes we'll need are 5/32, 1/8, and 1/16 inch. We'll also need some brushes, either with brush or foam applicator tips for the laminating epoxy we'll be using to strengthen the nose cone. We like small stir sticks for mixing epoxies, and a large applicator as well for some of the bigger sections we'll be trying to reach in to apply adhesive far inside the tube. Mixing cups, I like a small 1 ounce cup and a larger 3 ounce cup for different purposes during these videos. And in terms of the epoxies, we'll want a 5-minute epoxy, which has a fairly short pot life. That'll be good for tacking things in place and not waiting a long time to cure that epoxy. And then also a longer 30-minute epoxy, which is going to give you a little bit more working time, and it's going to be able to smooth out a little better. And we'll be using that for your fin fillets and for laminating the 3D printed nose cone. In the laminating process, we're going to need some isopropyl alcohol. The concentration does not really matter. It can be anywhere from 70 through 99%. Anytime you're working with epoxy, I really recommend working with some rubber gloves of some sort. Really take your pick. They're commonly available now. And one thing we'll be using those gloves for is to apply a little isopropyl alcohol to the tip of the glove to smooth out some of our fillets. We're also going to need some cyanoacrylic glue. The super thin glue is good for strengthening cardboard and making it really kind of harden. And then a gap filling or a thicker CA is really good for providing actual adhesive units, for example on the railguide buttons. We do have some paper towels here. We only have a couple on the desk right now, but always have a whole bunch of those handy at your disposal. And finally, we have sandpaper, 2 different grits. One is going to be fine grit at 220, and the other would be a rougher grit at, say, 80 or 120 grit. All right, we're now going to go through the materials that come in the box for the SBR Rocketry 3-inch Fusion kit. This particular edition is the special edition Virtual NARCON 2022 edition, which has some distinguishing features from others, but we'll talk about those in a minute. First and foremost, we'll start up in the front. We have angle brackets and T-nuts and bolts for anchoring your motor retainer. We have 2 different motor tubes. One is a 29mm motor adapter tube and a 38mm motor tube. We do have centering rings for the 38mm motor tube, which are numbered 1, 2, and 3. We'll have to keep those straight later during the build. And we have these smaller 29 to 38mm motor adapter centering rings, which we will be building as a part of the motor adapter assembly. Inside this ring here, we have these plastic rivets for securing the nose cone to the payload bay. And those are removable with just your fingernails. And also we have a pair of rail guides, which we'll be securing to the airframe later in this video. We have a shorter payload tube and a longer airframe tube that is pre-slotted and pre-marked with a guide for applying the decals and the rail buttons. We have a total of 3 coupler tubes. These are 6 inches in length and 3-inch diameter. They fit nicely inside these 3-inch tubes. We have 3 laser cut fins made of plywood, and we have the Virtual NARCON specific payload bay assembly, which is designed especially to mount Arduino units, which are featured in a subsequent program in this Virtual NARCON. You also have a parachute shown here, which is not necessarily included in your kit. You could choose to omit that from your kit and save a little bit of money in case you have parachutes coming out of your ears like most of us do. But in this case, we have a 36-inch nylon parachute. And finally, we have nylon webbing for a shock cord. And that wraps up the kit, in addition to the fin alignment guide and 2 different decal sheets that are vinyl decals that we'll be applying once we've finished the rocket. So these are the supplies and materials we will need to assemble the motor mount. We're going to need the 3 centering rings that fit the 38mm motor tube into the airframe tube. We're also going to need the pair of T-nuts that we'll use to secure the motor retainer to the aft centering ring. And we're going to need the shock cord. Now, tools we'll need include a hammer, a ruler, gloves, stir stick, paper towels, 5-minute epoxy, a small mixing cup, some sandpaper, and in this case we're actually using the centering rings that we received in the kit for the motor adapter assembly as a tool to protect our work surface when we hammer the T-nuts into the centering ring. So for right now, let's work on just the aft centering ring. We may set the other tools aside. Okay, for this work, we're going to use the centering rings from the motor retainer assembly to protect our work surface. If you have a workbench that has a hole in the middle, that would be great, but right now we're going to take the aft centering ring. Note that it has an alignment guide here and it has 2 holes on the engraved side. This is the centering ring labeled number 1. You want to flip that over and take each of your T-nuts and align them into the holes on the back of the centering ring. Now it's going to help to have this pretty close to the edge of the centering rings here so that your centering ring doesn't flex much, but then just gentle taps are all it takes to recess these in there and to drive these spines that are in the back of the T-nut through the centering ring. So when that is done, it is more or less flush with the back side and protruding out the front side. If you do this gently, you won't disrupt much of the finished surface, but if you do knock some of the laminate on that side off, that's going to be okay. We're going to reinforce this whole side with epoxy later. So now we'll simply continue with the other T-nut, again mounting it into the back hole, in the backside hole on the centering ring, and gently tapping. So now we have both T-nuts mounted through there. And just to give you an idea of how this will work, is we'll take our angle bracket, mount it over that T-nut, and pass our bolt through. And you can simply finger tighten that bolt in. And then ultimately in the field you'll use a screwdriver to make sure that this angle bracket clips over your motor to make sure it stays in the tube rather than ejecting during flight. But for now we don't need the angle brackets. We're going to do a lot of other work with this and the other centering rings next. Now that we're ready to finally start working with epoxy to secure our centering rings and our shock cord to our motor mount, we're going to grab a pair of latex gloves, some 5-minute epoxy, a small mixing cup, a small stir stick, our drop cloth to keep our surface clean, and our assembled but yet unepoxied motor mount, including the shock cord. So the first thing I want to do is just make sure that we're using the 5-minute epoxy. We're going to get our gloves on, and if you use longer curing epoxy, it can just take longer in your process. It's not a tragedy if you have, say 10-minute cure epoxy, but 5-minute is a nice quick amount for doing the surfaces that we have here. There's times when we want to use more epoxy that will take a little bit more time to get into the positions we want it, in which case we'll use a longer pot life epoxy. So for right now, I'm going to set my motor assembly aside, and I'm going to grab my mixing cup, and I'm going to spot about 2.5 grams marking on the side of my mixing cup. I like turning that around facing the other way so that I can see it from the backside. And I'm going to start pouring. Depending on the temperature in your work area, your epoxy may be a little sluggish. There's no rush once you've just got one of the reagents in here. I see now that as it settles down, I've come up to my 2.5 gram or 2.5 milliliter marking there. And these are equal parts. So we're going to do another 2.5 milliliters up to 5 milliliters with the hardener. And at this point your clock starts ticking, but you want to give it time to settle so that you make sure you have equal parts, because right now it's a little cool in my work area and I don't want to get too much hardener in there for the relative amount of epoxy. So I should have a total of 5 milliliters of epoxy mixed up. That's the two parts, and from this point on my clock starts ticking. So I'm going to check my watch and make sure that I'm ready when this stuff is near the end of its pot life at about 3.5–4 minutes. It's going to start to heat up and get gunky, and then it's really going to set up after that. So once I feel the heat coming on in the bottom of the cup, I kind of pay attention with my gloved hand. I need to be ready to wrap it up. And if you need to, just give it a break, get another cup, and you can keep working with another set. So the first thing I want to do is make sure that my centering rings get secured. I'm going to tip this up on its end, and the first thing I want to do is make sure that my T-nuts are secured. It doesn't take a lot, but I made a slight mistake there. I got some epoxy in the hole there. So it's okay. I wiped it out with my epoxy stick. What we want to make sure we do, being a little neater than I was that first time, kind of just apply it to the sides. You don't want to get that epoxy into the holes. You can work it all the way around here where this belongs on the centering ring though. So we're basically adding a fillet, and you can pretty much mark that out with the edge of your popsicle stick. And if you get some of your shot cord in there, no big deal. It's going to be secured to the airframe or to the motor tube anyway. But I want to get a generous amount in there, but I don't need a lot on my centering ring. Any that's on the centering ring just stands to get in the way of my fins, and we don't want to interfere too much there. So as I go along, I'm kind of smearing it into the joint between the centering ring and the motor tube, and then I'm coming back around with the tongue depressor flat, making sure not to get gunk in the hole on the T-nut. I'm kind of creating a little fillet and smoothing it out on the centering ring. And as soon as I'm ready, I'm going to move up pretty quickly to the middle centering ring. I'm working only on the top sides right now, because we don't want this to start dripping down and getting in our way. Dripping all over the place. I am working on the drop cloth, so I'm not making too big a mess. And I'm going to go smack over that shot cord. I'm going to keep an eye on my watch. It's been about half my time, so I'm at halfway done. I need to be hustling up here. That shot cord is kind of going to get slapped in place with the last of my working time. And this is all going to be inside the rocket. I'm feeling it start to heat up now, right about 3 minutes. So I'm going to try to avoid the shot cord as much as I can. If I get some on there, it's all right. One of the important things is to not get any of this epoxy in the end of the motor tube. If we do that, you're going to have to either wipe it out with some isopropyl alcohol right before it sets up. But if it sets up, kind of the jig is up. And you're going to need to remove it with a Dremel later. So with the fundamentals of my centering rings secured, now I'm going to use my last little bit of time here before my epoxy sets up to apply this to the motor tube and to sink the shot cord down into that epoxy. My timing here is pretty much perfect. I've got just 1.5 minutes left. I'm expecting this to really start heating up now. I'm going to smear especially the edges down. Make sure that it is nice and secure there. I'm not going to worry about getting every little inch of it secured down because there's plenty of surface area that's connected now. At this point I'm feeling pretty good about it, but I'm going to wipe the rest of my uncured epoxy out and just try to smear it a little more onto the edges. And I can tell now that this is starting to set up, and so I'm going to let it be right now. At this point I'm going to take a minute to kind of check over everywhere I've got epoxy and just make sure I don't have it in places I don't want. I don't want it anywhere inside the motor tube. If I do, right now is the time to just really quickly take your gloved hand and wipe it out of there. If you need some, isopropyl alcohol will help move that right out. But now is the time. It's now also the time to double check the aft end too. Make sure you don't get any there. and just make any last minute adjustments you want to the alignment of those center rings. But I'm pretty happy with how these have come out. And right now, it's exactly 20 seconds before the end. I can feel that what epoxy is on my fingertips is a little bit warm and it's getting tacky. So at this point, I've done what I need to do and I am happy with the result. Okay, about 10 minutes has passed and we're going to find that our epoxy is mostly set up. It'll still be a little bit tacky to the touch, but for the most part it's certainly not budging anywhere now, and we can double check that things are in good shape. One thing that's important to check is to make sure that you did not get any epoxy inside the threads of the T-nuts. Might be worth taking one of the bolts and just hand tightening it in there to make sure it goes all the way through. And that first one I made a little bit of a mess on, but it looks like I came right to the edge of the threads and did not get any in there. So you're going to want that bolt to be able to insert all the way through without running into the adhesive, and I'm in good shape there. But double check that, and again make sure that you've secured the back of those T-nuts with a little bit of epoxy, but right around the edges only. So the next thing we want to do is, it's a little trickier to balance it this time. We're done gluing the forward end of this, so we're going to be able to tuck that shot cord all the way up there and stand this on its end. It'll be a little bit crooked, and that's okay too. What we're going to do now is we're going to work on the aft end fillets for each of these centering rings. So for that, we don't need quite as much epoxy because we are not worried too much about epoxying down our shot cord anymore, because it's nicely secured. If you think you need a little bit more epoxy on that shot cord, go ahead and add it. But while we're going along here, we're trying to make sure that we keep this area here clear of where the fins are going to be. So we do have some epoxy smeared here, but it's super thin. I don't see a problem with that at all. What you want to avoid is a big glob of epoxy, and we do have some of that right on the shot cord, but that's not where fins are going to be, because fins aren't going to stick well to there. So we're going to be putting fins right about here, and then on the back side as well. So I'm happy with how things have come out. I'm going to mix up about 2 milliliters of epoxy in my cup for the next go around. It gets a little bit harder once you start reusing your epoxy cups, but I'm just going to kind of eyeball where I think this needs to be, using a little bit less than I used before. In part because one side is probably pretty decent coverage. The key thing is you get the epoxy amounts more or less equal, and that's a bit of a judgment call. But there's in this BSI two-part epoxy, there is a pretty good tolerance for how much you can be off your 1-to-1 ratio. Some people like to use a scale to measure that a little more accurately, but I find that with a little bit of experience, eyeball is fine. All right, so remember our clock is ticking again, so I'm going to check my time and start working. I'll start down at the bottom, which is actually the forward centering ring in this case, and I'm going to smear it all the way around. Now I have dripped some epoxy on this drop cloth, so I'm glad I'm using it. I don't always concern myself with what's on the table because I use this drop cloth method. Again, I'm not concerned about getting 100% coverage around this whole fillet. I'd rather avoid the shot cord to prevent any potential breakage later on. When I get to the middle centering ring, however, I'm just going to go right over it because it's already on there, and on this side of the centering ring, it's not going to have any chance of coming off at a weird angle. You see that my drop cloth is spinning with my application, because I do have a little bit of tacky epoxy on there that's stuck to it a little bit, and that's okay. On this side, the side that's going to be facing the fins, I'm making sure to get that to minimize the fillet here, in particular to minimize the amount that winds up on my centering rings, because I don't want that to prevent centering rings from inserting well. As I'm now up onto the third centering ring, the aft centering ring, I'm making a point to avoid the T-nut holes. It's just like on the other side, we don't want to find out later on that we've blocked one of our T-nut holes. I've used a good amount of epoxy again here. I'm well inside my time. I'm only about halfway through now. I'm just making sure to smear that into the seam. At a later point, once we have this all inserted and adhered to the inside of the airframe tube, we're going to go ahead and coat the whole back side of this centering ring. But for right now, I'm just focused on getting a good, neat, clean fillet. I'm taking the opportunity, since I am not using a screw-on motor retainer on the back side here, I'm taking the opportunity to go ahead and apply some epoxy because I have the extra and I've still got time. I'm applying that to the outside of the motor tube. Being real careful though, not to get it on the inside of that motor tube. I've double checked that, it's not in there. But now is the time to fix that if you get it in there. So I'm really happy with how that's worked out. I'm just going to park this right now. I made sure not to get any in the T-nut holes. I don't have any in either end of my motor tube, and gravity right now is pulling this down into that joint. And I'm just taking this moment to double check. My fillets are definitely solid in here, but they're not so big that they're going to interfere with the fins fitting later. So for now, we're going to give it another break and come back when this is cured. With the motor mount assembled and cured, all our epoxy is going to stay put. Our centering rings are ready to go inside the tube. We're going to do a dry fit of our fin can parts now. So we have the airframe tube, which if it doesn't already, make sure you mark a line directly between two of the fin slots for aligning the decals and the rail guides. You're going to want your motor mount assembly, the fin alignment guide that came with your kit, and the 3 fins, and then your gloves and 5-minute epoxy and your mixing cup and your drop cloth. So again, dry fitting first, just to understand how things fit and to make sure we are ready to move on. You may need to sand the outside edges of your centering rings to make sure there's a good fit, and it's always a good idea to go around the inside edge of motor tube with your fingernail and make sure that it's chamfered so that it's going to be easy to insert these centering rings. Starting in at an angle is helpful, and twist as you go. Once you get to the second centering ring, of course, you can't angle. And one thing we've discovered is that by aligning your shock cord that's glued to the motor tube with the exterior alignment guide, when you get all 3 centering rings inside, you're going to know that your T-nuts are not aligned with a fin slot in any of the positions. And we know that our shock cord is below the line and not under a fin slot. Those are the key things that you don't want interfering. Now right now you see this is almost flush with the centering ring is almost flush with the back end of the rocket. What you want to see is that if you push this too far in, you're going to see the centering ring slide up inside the fin slot. Likewise, if you pull it too far back, you see the middle centering ring, number 2, show in the forward end of the fin slot. By measuring these with the fins earlier, you made sure that you've got just the right amount of space that you can hide both those centering rings on either end of the fin slot so that they are just peeking out one side or the other. We know that they're just out of sight. And to make sure this will fit, go ahead and do a dry fit with your fins. Insert them in there. So there's 2 sides to this fin. We want the longer, pointier tip toward the forward end of the rocket this way. And you should be able to wiggle this back and forth and feel it against the motor tube. And feel that there's not a big glob. If you wiggle it back and forth, forward and aft, you should feel that it sits flush on that tube. Go ahead and do that with all 3 fins, making sure you get the alignment of the fin correct. Again, just wiggle it in there. We're not worried about precise alignment. Use your third hand to make sure all 3 fins fit in. It's worth tipping it up on end on your fin alignment guide to practice working with that fin alignment guide. Because in the end, what you're going to want to do is have this aligned in the middle of your fin alignment guide on the 3-inch tube marking and be able to look down from above and make sure that all 3 of your fins are in line with the thick lines used for the 3-fin pattern. So with that, I know that my fins are going to fit in this model, and I'm going to go ahead and glue in the motor mount. We are now ready to glue the motor tube into the airframe. What you're going to need here is at least 150 millimeter long, that's about 6-inch effective length glue applicator. We're going to use this to reach glue placed on the tip, or epoxy actually, all the way up inside. You see right here we are very near the top of the fin slot. We want it to be able to reach just forward of the fin slot so that the glue that's on the tip does not gunk up the fin slots unnecessarily. So for that, I'm going to make sure that we're reaching at least that 150 millimeters in, and we're going to be placing the glue just on the slot. For right now, I want to set the motor mount assembly off to the side, and I'm going to mix up about 5 milliliters total of epoxy as we had originally on the centering rings. And we're not going to put an enormous amount of epoxy in here. We are primarily looking to keep the epoxy in a nice thin bead at the forward end of the centering rings. And for this step, we're only going to be epoxying the forward centering ring in. Once that cures, we'll flip things over and start working on the other side. Okay, check your time so you know how much you've got to work with. I'm going to serve up just enough epoxy from my small stir stick onto the end of the applicator, right like that. So it should be less than a third of what you're doing, and I'm going to insert it at least up there, and I'm not even going to put it near the slots. I'm putting this really right up on the side of the tube, kind of right directly between 2 slots. And then I'm going to flip this over so that it's at the bottom. And then I'm going to repeat. A nice generous dab of glue there. It should be just enough to fill the end but not drip off too badly. And pull that up there. And again, I'm going right between the fin slots. I'm not trying to get this right up to the edges of the fin slots. That's just not necessary. And it just simply increases the risk that you'll wind up gumming up the fin slots and making it difficult to insert your fins later on. Do a quick check to make sure I'm inserting this in the right location. Smear it back and forth. It is okay, for reasons we'll see later, not to have a solid bead of glue all the way around here. So in that tube, you'll see adhesive in 3 primary areas between the fin slots up near the front. So before things get too tacky, knowing that our centering ring is fitting well, we're going to insert and again align our shock cord with the outside line on the airframe, double checking our T-nut locations. And we've now inserted right until we see that our forward centering ring is just out the range and our aft centering ring is also just out of range. And we're going to set this upright to dry. Now in my case, I've got just a little bit of space under my airframe. And that's okay. I'm just going to have this on my drop cloth until that is ready to dry. I'm going to check down from the upper side, and I see that I have a good bead there in some locations and not others. That's okay. We're going to have this this tube stiffened with an upward coupler. So we're going to have multiple ways that we are securing these fin slots. For the sake of our next step, I've already mixed up about 3 milliliters of 5-minute epoxy. and suspended the rocket from the side of the table here so you can see it in the camera. In practice, you could put the rocket down on the floor and work with it that way. What we want to do is spread a nice thick coat of epoxy inside the aft centering ring section here, basically coating all of the paper, but keeping it out of the threads for your T-nuts. And basically we're doing a couple things here. One is we're trying to protect the paper and wood from the heat of the motor exhaust, and also from the impact of landing. And we're anchoring that aft centering ring to the airframe tube. So again, as long as you're being careful here, I'm checking your timing on your adhesive. We're going to be just fine, making sure not to get any inside the threads. If you're a little paranoid about getting some in the threads, you could apply Vaseline to the provided bolts for those T-nuts. But I find the bolts tend to get in the way a little bit more, and I'm better able to stay out of their way than if they were inserted there and doing their job keeping me out. And at this point I can see that I've got it quite well coated. There were some areas on the rear centering ring that kind of cracked through as I hammered home the T-nuts back in the first couple steps. But I can tell that it's well filled with the epoxy, and I've really only got just a little bit more time on this. So I'm kind of smearing around on the side of the tube, but again, being super careful to stay out of those T-nuts. And I'm hitting both the motor tube and the airframe tube, make sure there's plenty on there. And I'd like to stop fiddling around here with time so that even this fairly thick 5-minute epoxy has the opportunity to just kind of settle out and have a smoother finish. And so here's where I'm going to stop it, even though I'm only about a couple minutes in. So next we're going to make sure that our forward end of our motor mount does not come loose by inserting a stiffener coupler inside the front end of the airframe tube. Now right now we've had our forward centering ring epoxy dried for some time, so we're not going to get stuck in tacky epoxy there. And what we're going to do is a dry fit test first of all. So I'm going to take one of the 3-inch couplers. These are 6 inches long, so you're going to be able to slide one in and it's going to go past the end of your tube. You can take the other coupler, again dry fitting only right now, and use it to help slide that in. So your that first coupler tube is well down inside of there. Take your Sharpie and mark that location. Now we're going to find that location is probably more than 4 inches inside the tube. Go ahead and pull that coupler out of there. So you now have a mark 4 inches inside your tube. We're going to now mix up some 5-minute epoxy and smear it in a bead well past that line. I'm going to make sure it's at like 150 millimeters. Pass it well down there and get it well below that line. You do not want any epoxy up here near the in the first 3 or 4 inches of your tube. If you do that, you're going to get some difficulties with the couplers that you'll use for your payload tubes sticking later on. And when you do that maneuver with epoxy next, we're going to slide one coupler in and twist it as we go, and then it's going to be pretty tough once it gets to a certain point. You're going to want to take that other coupler and shove it through the epoxy all the way down so that the first coupler seats well against the forward centering ring. This is part of the strength of your rocket, making sure that that forward fillet is good and secured and the tube is thicker right at the centering ring so that it's going to be a strong tube during flight and landing. Now what you're ultimately going to do is you're going to be pushing that epoxy bead down toward that forward centering ring, and it's going to form an additional fillet down there, which is exactly what you want. But you do want to be careful that you don't wind up getting some of that epoxy into the motor tube. There shouldn't be so much that you'll run that risk. So now that we've dry fitted and kind of understand the maneuvers, we're going to glove up and go ahead and mix up a fair bit of epoxy and do this all in one fell swoop. All right. We've just mixed up about 5 milliliters total of 5-minute epoxy. And we're going to start applying that carefully like we did before. to the tip of our applicator stick. And we're going to make sure that we apply that in a generous bead inside the tube, but we really want to be careful not to get any of this dripping down the side, which can be a little tricky if you're not careful. So we look for our mark and we smear it smooth. And we're going to keep doing this. Remember, we're going to wind up covering a solid portion of this inside of the tube with this epoxy smeared down inside. So we want to make sure we're getting well inside, but all the way around the tube. And again, every time I bring the stir stick out, I want to double check that I haven't dumped any in the first 3 inches of that airframe tube, because if we do, we're going to have some spacing issues with our coupler that needs to secure the payload bay to the airframe. All right, so now I have a good coating well inside there. It's nowhere near the end, and so I'm going to take my coupler. And the first little bit, it can slide easy because there's no real issue, but I'm going to pretty much have it ready to go. I feel it starting to hit the epoxy. I push it in as far as I can and then quickly take my other one and pull it out. And so that's done. You can't see anything in there on the video, but I know that I got that in and out cleanly, and I can look inside here and see that there's nothing near the forward end of my airframe tube. So I did a really clean job of that. And now what I'm going to do is I'm going to tip this upright and let it cure. And when I do that, I'm going to take a look inside and make sure that I don't have anything near my motor tube. And it's all pretty good. I see the bead build up there, and it's got a solid fit on the forward end of the centering ring, but it's otherwise in great shape. With our motor mount fully secured inside the tube with our stiffening coupler ahead of it, it's now time to get back to the fins. So we're going to need our fin alignment guide, our 3 fins, and our airframe, which I'm going to prop up here on our fin alignment guide, get it as centered as I can. You may be able to see I've got a little bit of space below my airframe tube because the motor tube is just it's a smidgen toward the short side of 1/2 inch from the end of the tube. If you're right at 1/2 inch, you're going to have the 2 tubes flush. But I'm basically just trying to make sure it is centered and that the fin slots are aligned with the thicker of the lines on our sheet. I've already gone ahead and test fitted my fins, so I know that they fit nicely. I can feel that there's epoxy on that tube, but I can fit these things in nice and securely, making sure that I have the correct end of each fin. That is, the longer tip is pointing toward the forward end of the kit. So with that said, I know we're ready to go. What we're going to do next is mix up some epoxy, and in fairly short order, we're going to apply epoxy to the whole root edge of the fin, insert that into the fin slot, wiggle it back and forth just a bit so we feel it's good, and make sure it is aligned by looking down from the top of the airframe onto the tube. We're not going to have a view on that in this video, but that is what we're going to do. Okay, so we've mixed up a generous portion of epoxy, about 8 milliliters total. We're going to draw it across here onto the edge of the root fin, on the root edge of the fin. Now it can be dripping off there, and you kind of want it generous enough that it's just barely sitting on top of the root edge. It wants to kind of ooze off of there. Again, making sure the correct edge of the fin is in. You get it on there, and you've got a little bit of time before things get woolly. So I'm going to make sure that fin is in, and it's going to stick pretty much on its own, but you should feel it rub against the motor tube. And I just kind of felt that rub around a fair bit, so I'm going to repeat this. We basically did it once. What that did is it just smeared a bunch of epoxy on the motor tube. Some of it came off on the side of the fin slot, but most of it was right on the motor tube. And so I've just repeated that, so it's going to be doubled up, a little thicker application. It's going to be stronger on the motor tube. And remember, this is an area on the motor tube that we made sure to roughen up with sandpaper. So it's already a good rough fit. Again, always make sure that your fin is pointed the right direction. If you make a mistake, it's not really a big deal. It's not going to fly terribly differently. But from an aesthetic standpoint, you may be a little frustrated that you've got one fin going the wrong direction. Well, they're all the right direction. It's just a matter of different directions. So you wiggle it side to side just a bit. And right now we've got kind of a mess right along some of the fin slots. Before this cures, and we're just about getting out of, we're running out of epoxy faster than we're running out of time. But as soon as this cures, or before it cures, we're going to go through and smear those fillets, smear the areas that will be covered by fillets smooth. I'm seeing that I used a little more epoxy than I needed to. I've got a good 2 grams left, so you could probably get away with 6 milliliters instead of 8. So now that I've got all those in the way I want them, I'm going to be prepared to look down the top of my tube and make sure my fins are aligned well. And I'm basically just going to babysit here. See, this fin started to pop out. That's okay. I'm going to take my gloved hand and run it up there. In addition to gloving, you should have some isopropyl alcohol. 99% is what I'm using. Simply flash a little bit. I made a mess on the table there. That's okay. This will clean up easily. That isopropyl allows your finger to slide much easier across the epoxy. It's going to smear it a little smoother and make this easier to follow up with the fillets. So I've eliminated the drips that were going on, and now I'm basically just recentering it and making sure that the fins are sticking straight out from the tube along the lines outlined in the fin alignment guide. And I'm making sure that as this epoxy sets up, that that they're still aligned and still inserted. This one likes to come out, so I'm going to have to just really babysit this. These are going to want to rotate out, so if you simply hold the top, you'll be in good shape. Okay, right now the epoxy on the fin can is curing. It's set up well, but I want to give it more time to fully cure before we turn it on its side to work on fillets. For right now, we're going to use some of this epoxy I just mixed up, and we're going to work on adding the bulkhead plate to the coupler that we're going to later insert into the 9-inch payload bay. What I've done inside is I've basically taken in place about 1 inch or 1.5 inches and marked a line inside there. I've also marked a midpoint on this coupler tube that's right at 3 inches. So I've used my ruler and Sharpie to do that. What I want to do now is take my applicator stick, and I'm just going to use the stir stick. Go ahead and apply epoxy right in there, right on that 1 to 1.5 inch line. Exactly where you put this in there does not matter. This is not really a visible part of the rocket. It's good to have it pretty close to the end, but you want enough space on there that you can easily get at the shock cord, and that it's not pulling from like the middle up at 3 inches. So I've been pretty sloppy about a really quick bead of epoxy here. I've got a little bit more, so I'm going to make sure to use that. And what we're going to do now is we're going to insert the bulkhead and push it all the way up through there. Doesn't really matter which side you want down. I'm going to go this way. And the key is here, pushing it up into that fillet so that you build up a nice big fillet ahead of it all the way around. And you want to make sure that you've established a good bead pushed ahead of there, and that's what's going to keep this from coming through the front end. Take a look at the back side, make sure you've got that pretty much level, and then flip this right side up so that that bead of epoxy just sits back down there on top of the bulkhead plate. Now while this is drying, we can mix up another batch of epoxy, and we're going to repeat a similar trick here. Again, trying to put a mark inside the payload bay tube, about an inch or inch and a half inside there. I'm going to go for that longer line at an inch. And what we're going to want to do I'm going to use a secondary coupler just to demonstrate. We're going to get a big sloppy bead of epoxy in there, kind of right between those two lines, all the way around the tube. And when we have that epoxy in there, we're going to insert just the very tip of this coupler in there so it's not in the epoxy. Now that we're straight and aligned, we're going to push and twist right up to our midpoint line, and that's how we're going to go about this. Okay, we've mixed up a batch of epoxy. We're going to find our marking inside our tube, and we're going to get to applying that so that we can mount this bulkhead assembly in there where we want. So one thing I did is I accidentally just dripped a little bit just inside the payload tube, a little closer to the edge than I wanted, and I did it again in an even worse way. That's going to make it a little bit hard to get this started as cleanly as I would like. Ideally, what you have is you don't have any excess epoxy right near the edge of your tube, and that allows you to set up that tube before you kind of go full bore and twist it all the way up in there. I'm doing a little better job, and what I have slid in there is pretty limited, so I'm not too concerned. I did twist a little higher than I want to, so I'm kind of going back with the remaining epoxy and making sure it's applied down where I want it. At this point, I've kind of messed up the edge, so I'm going to come pretty close here and just kind of smooth in where it is. So we've got that good. This is setting up well. It was already hot, and now it's gone cold again. We're going to insert this to that halfway mark we made before, kind of in one twisting motion. The twisting is important because it allows that tube to really get coated with as much epoxy as you can. And just like on the, just like we had in our earlier adventure, we've got a fillet down there on top of the bulkhead and now also on top of the coupler. So we're just going to leave this upright to cure right here on our drop cloth. Okay, while the rest of our epoxy is curing, we're going to move on to our nose cone assembly. So you're going to need the last of the 3 couplers that came with your kit and the 2-piece 3D printed nose cone assembly. And as you see, these fit together pretty nicely with a snug fit in the 2 pieces. Our job is going to be to glue these together and then to apply glue to the inside of the back end of the nose cone and insert the coupler. So that's what we've got next. We've already mixed up some epoxy. When you're assembling these, anytime you're making any mating parts, you got to think about where your epoxy is going to go when it gets applied. I'm going to apply this on the inside of the forward end of this because we've got an inner lip on the aft end. And if we applied it the other way around, when you put the 2 parts together, your epoxy is going to get shoved right to the outside, and that's not what you want. What you want is to apply it to the forward end so that the clean end that we're about to insert here pushes the epoxy up into the inside of the nose cone. It's just going to make a lot less mess, and you're not going to have as much to clean up when you're done with it. So there we've kind of been all the way around. I'm going to take my aft end of the nose cone, and again with the twisting motion, make sure that gets in there and is nice and snug. Now is the time to take your finger and smear this a little smooth. Now we're going to be laminating this whole nose cone with epoxy, so it does not need to be pristine. It's okay if you've got a little bit of that left, but I have very little that wound up on the outside. But our clock is still ticking, so we're going to repeat this procedure, putting a generous helping here in the inside aft end of this nose cone. I've pretty much used up all my epoxy, but I'm pleased with the amount that I have available. Now we're going to insert our tube right up about to the midpoint, but it basically is going to stop where it wants to stop because there is constrained space up here. And I feel that in a good solid way, and I do not have a lot of excess epoxy on this whole assembly, so I'm pretty pleased with how this came out. Okay, With the fin can epoxy fully cured on the inside, we're going to go about applying the fillets to 2 surfaces at a time, opposing fins on either side of the tube section. And we're going to use 30-minute epoxy. We're going to fill it in there and use an isopropyl covered fingertip to kind of smooth that into the joint to make sure it bonds well. Just to help keep the tube upright, I'm using the angle brackets from the motor retainer to keep this tube upright. You can get fancy with a cradle, but this is going to work just fine for what we're doing. So what you need are your airframe tube, your drop cloth, your mixing cup and stir stick, some 30-minute epoxy this time, isopropyl alcohol, gloved hands, and some paper towels. All right, we have our 30-minute epoxy mixed up, poured about 4 grams total here, so 2 grams of resin and hardener. And I like to drip this right in the middle of that fin for starters, because you never know how far it's going to go. And I don't want to go to the edge until I'm actually working with my gloved hand instead of this kind of clumsy applicator stick. So I'm going to put the right amount, and that'll take a little bit of learning to do. But that, I believe, is about the right amount for the fillet I'm going for. Like I said, there's a lot of different opinions on how to do fillets or how thick to make them. I'm going pretty minimal on this just because this is a pretty basic kit for me, but if you are really going for aerodynamic shape, you can do all sorts of things like shape your fin leading and trailing edges, make really aerodynamic and super smooth fillets on here. But for most level 1 flights, performance is not the key, reliability is, and doing a good job on your build is a lot easier when you're not dealing with a lot of concepts that are totally new to you. So again, anytime like in this case, I went back and added another little bit of epoxy, and that was just because I wanted to get it a little bit thicker. I thought, within reason, the thicker you get this meniscus, that's this little triangular shape between the fin and the airframe tube, the more strength you're going to have because your epoxied surface is longer. That's the big purpose of this. So even right now, just without doing any work on this, you can see that these are pretty straight surfaces. What I'm going to do now is dig into my isopropyl alcohol. Try to work over my drop cloth so I don't make a mess like I did earlier. And basically just slosh it a little bit on your finger. In this case, I wound up on my middle finger more than anything else. So I like to start in the middle and work toward an end and then come right back, because you don't want to push that off the end. But you just use that finger to smooth that in there. And have a paper towel handy, because right now I've got more than I need. I'm going to use my finger to kind of straighten up this fin side edge, and another finger to smooth that in. And that's going to be a pretty good fillet on there. I'm going to repeat on the other side, and we'll be good to go, and we'll repeat that another 2 times to finish up. Okay, about 10 minutes has passed, and you can see immediately from just taking a look at these fillets that gravity and the gloved finger tipped with rubbing alcohol has done a fabulous job of smoothing these out and making them look really very nice. And that's one of the beauties of working with these materials. Now, the one thing you want to do, it's sort of the downside of that same feature that it takes so much longer for this epoxy to cure, is that you could wind up getting some that drips off the end of your fins up here and over here. So just keep an eye on that during these 30 minutes. Keep checking in on it, and if you have any, again, just take a gloved hand and wipe it up there, and then wipe it on a paper towel. If you're curious about how close you are to being finished, you're going to be really frustrated if you go and stick your finger in it to see if it's solid and discover it's not, and you've kind of ruined that beautiful finish. So I like to keep a little bit of the epoxy in my mix cup handy and just come here and dig in there with the stir stick. And what I'm seeing is it's starting to get tacky, but it's still plenty gooey, and I definitely wouldn't want to touch my fillets. So I'm just going to leave it for a little bit more, having checked on it every few minutes. Toward the end of it, it's going to start to get tacky, and that's when you really want to make sure to have your edges clean, but try not to touch any of the great finish that you've got going there. All right, with our fillets still drying, we're going to move on to laminating the 3D printed nose cone. Now we're doing this because the 3D printed material itself, it's made of PLA, and it tends to be a little bit brittle. So we're going to be adding epoxy to strengthen this, both on the inside of the nose cone and on the outside. So I've mixed up some 30-minute epoxy. We're going to then go ahead and thin it with isopropyl alcohol. Exactly how much alcohol to use is a matter of judgment. You want it to be thin enough that you can brush it. Right now what we've got is something that's pretty runny, but it's not really brushable yet. If we tried to brush that, it'd all gum up in one place and make a mess. So we're going to be adding isopropyl to thin it out. We're going to be working with, in this case, foam disposable paint brushes. You could use bristle brushes as well. You'll notice that one of them I've gone ahead and just taped it onto a piece of scrap from the laser cutter, and we're going to be using this to reach all the way inside that nose cone to laminate all the way up toward the tip. And that's where we're going to start. So I've mixed up my epoxy so I can set this aside. I mixed up 10 milliliters of epoxy total, so I'm going to think about adding about another milliliter, but this is not an exact science. I'm going to add a milliliter at a time. Maybe that was 2. And I'm going to mix this and see how I like the consistency of what we get. You're going to need to make sure to mix this really, really well. Initially it was kind of lumpy and didn't really like to homogenize, but now I'm seeing it's really very much so, and it's like thick milk is, I guess, a good way to describe it. So if you have sweetened condensed milk, that's a little thicker than this is, but this is not really quite as viscous as actual milk. So with that done, I'm happy enough with this. I'm going to start on the inside because that's going to be a lot less messy to work with. So basically I'm dipping my brush, and again, you see how this drips off. It's pretty runny. I'm just trying to stay over my my drop cloth so I don't make a mess. And it is okay if you get some on the inside of that nose cone coupler. You don't want to get any on the outside of the coupler, which is why I've put some painter's tape on there to protect it from when I'm working the outside. I'm going to go all the way down to the bottom and just smear it around. And you can feel it wants to stick. This is not just water we're putting in there. And what my strategy I'm using here is I stick it as far in as I can and wipe back and forth, rotate it a little bit, and do some more. And we're going to work for a little bit and then check our progress and make sure we've got all the areas we want covered. And I'm mainly working the forward parts of it now. I'll be able to see a little bit better what I'm doing when it comes out a little bit. And what I'm seeing is that I've made a pretty good mess all over the inside there, so we're pretty close to being ready to finish up and be done. So what you can see in there, and you're not going to be able to see it well on camera, but you see a lot of greasy spots. You can see where the coverage is good and where it's not. And I'm just basically going to keep going until it's all covered. It's sort of like the Zamboni at the ice rink, says the guy from Arizona. Alright, so I'm satisfied with the inside coverage. Again, getting some on that cardboard coupler inside does not matter. So I'm going to go ahead and, using the same brush, looks like my 10 milliliters of epoxy was enough to do both surfaces. In the end, we're going to wind up letting this cure in the upright position, so we're going to want to basically suspend it over the drop cloth here, because it will be dripping off some. I expect that this will ooze down. Because I've covered the base of the coupler, I'm going to go ahead and do a full round right around there, because I can still lay the tip of this on my table and not make a mess. And I know I can get a little bit of this brushed on epoxy on that tape, and I'll be able to peel it off later. Painter's tape isn't going to stick hard to your coupler wall, so that's going to make this a safe choice for your paint choice, or for your painter's tape. So now that I've done that base layer, I'm basically just going to keep moving up the nose cone, making sure that I've filled all the pores. when you get to this the seam that we glued with 5-minute epoxy, you're going to find that it wants to soak up some of the laminating epoxy we've made. And that's because there's just some gaps inevitably, and filling those in is great. You're going to see a little lip there that's going to want to be sanded later, and that's good. I'm prepared to lay this down like this because I'm getting toward the end of my epoxy now, and I want to be able to get all of it out I can. So I'll work two-handed there and get all of this covered. Just like on the inside, you can sort of see where it's dry and where it's wet, so you're going to need to rely on your light to keep you informed. And the beauty of laminating epoxy, whether it's official laminating epoxy or homebrewed like we just made, is that it just likes to fill the gaps. It smooths itself, and you can kind of keep going over it at this stage, and you're not going to see the brush strokes. Where you see a spot you haven't quite covered, you just repeat it. And even when you're pretty much out of epoxy, you can smear what's around there and soaked into the brush, and it'll be all right. So what I'm seeing is I think I'm done. So I'm going to hang this upright somewhere I can let it drip and not make a mess. All right, while we've been working with the laminating epoxy and the 30-minute epoxy fillets, our payload bay has completely cured the fillets and the coupler on the upper side. But if you look down here at the aft end of the payload bay, where you're going to be attaching the shock cord, we need to make sure there's a good epoxy fillet holding this bulkhead from tearing out at maximum shock cord extension. So we've mixed up some more 5-minute epoxy, and we're simply going to do the simple job of smearing it into that corner. Totally missed the first time there, that was pretty awesome. But we basically just smear it in there all the way around, so that there's going to be a lot of force on this joint. So we want to have a nice strong bead built up, joining the cardboard to the plywood. And it's insufficient to just have epoxy on the other side holding it on. Then you're relying on the chemical bonds to keep it all together. Adding the physical barrier of having epoxy that is wider than the bulkhead is the key aspect here. So I'm kind of trying to scoop this down as I go along off of the wall of the tube to form a nice thick fillet. When you're done with that, simple enough. You simply set it upright and let it dry in the upright position. Okay, now we are in the process of applying the fillets to the fins. So this side doesn't happen to have them yet, but the others have cured up nicely. But we're going to take this opportunity to drill holes for the rail buttons, which we will be attaching after the rocket is finished. But we want to get the holes drilled and hardened now. So the instructions indicate to make a mark 1/2 inch above the aft end along the rail guide marking line, and also 8 inches above that. So a total of 8.5 inches above the front. In measuring my own tube, I measured down from the forward end to find it was just about exactly 10 1/8 inches to the forward centering ring of the motor mount. If you want to have a little extra security with your rail guide, I recommend you measure down from the front and add just 1/8 of an inch to your measurement there, so you can land that rail button contacting the forward centering ring. That's going to give you a little better anchor to glue your rail button in, and that's what we're going to do. I marked both on here. You see there's a little bit of a discrepancy between the 8 inch from the instructions and the 10 inch that I measured down from the forward end. So I'm going to go with the 10 inch on mine. So what you want to do is I'm using an electric drill with a 5/32 bit, and you simply carefully and gently drill through the tube in both places. And what I felt there is I'm right next to the forward end of that centering ring, and that's going to give me something to attach glue to so that those rail guides don't unthread. Now this is kind of a mess right now. What we're about to do is harden this with super thin CA. And to do that, we're going to want to take an X-Acto blade and carve away any excess so we can see what we're doing here. I've got just a little bit of the cardboard that curled up and it's kind of sitting in that hole, just being difficult. So you just kind of want to clear that out. And take your super thin CA. Super thin CA is going to basically just permeate this material and wind up strengthening that, hardening the cardboard as it were, so it becomes a sort of composite material that is much stronger than you might think. We're going to have to let it cure fully, and when we do that we're going to re-drill this with the same drill bit so that you've got a good clean margin and you're going to be able to fit your rail button screws right in there once you've finished everything. When you do, your rail guides are going to look like this little guy with a beveled side. That fits the bolt. They're going to fit right in there. You see this is a little bit tight, but that's not really going to be strong enough without some adhesive in there. So we're going to recommend using some gap filling CA or extra thick CA glue. We're going to add, when it comes time, you're going to add a drop in there after you've painted the rocket the way you want. If you want to apply the vinyl decals, go for that. Once it's all finished, this is basically the last thing you do to finish your rocket. You're going to put the CA glue into the hole and then use your screwdriver to screw that in so that it anchors nicely to the airframe tube. And if you position it just like I did, it's going to wind up being right next to the top end of the centering ring, which is right about here, and you're going to be able to see that you've got that glued in well. If you need to, you can go in there with a long stick with some epoxy if you need to add a little extra strength to it. On the aft end, we're going to wind up being right in the centering ring, and so that too is going to wind up being a nice strong mount. But for right now, we're just drilling the holes and we're hardening, and we're going to deal with the re-drilling and the mounting of the rail buttons after finishing. Interestingly enough, as it turns out, the difference between the 10.5 inch from the forward end of the tube measurement that I use to put my rail button hole in and the 8.5 inch from the aft end, the instructions indicate, is exactly a 1/2 inch. And where this becomes interesting is that the instructions also call for a vent hole in the upper chamber of your airframe tube to allow the pressure inside the tube to equalize with the atmospheric pressure. If this rocket is going more than a couple thousand feet high, you could have a case of early separation if your pressure inside the airframe tube exceeds the atmospheric pressure outside. It could push your payload bay off and deploy your parachute early. So we're going to drill a 1/8 inch hole, which is slightly smaller than your 5/32 for the rail button, right through the wall here. And this is going to be going through both the coupler and the airframe tube and the coupler tube. And with that hole there, it's not enough to prevent pressurization on ejection, but it's enough to allow for pressure equalization as the rocket ascends. And just like on the other one, you're going to want to harden this with a little bit of CA glue. And that's soaking in there. You don't see it in the video, I'm sure, but it's soaking in there, and you just let it dry. You want it to dry completely and then re-drill with 1/8 hole. So finally, we're actually starting to put parts of a rocket together. We're going to be connecting the payload bay to the airframe using the shock cord, of course, and we're going to use the large glue applicator that's now dried to push the shock cord up and out of the motor tube. And then we can reach even big fat hands into the 3-inch tube to get it out the rest of the way. So this is a convenient time to take the kinks out of your shock cord. It's going to get all kinked up all number of times during your use of this rocket, but it's sometimes nice to start with it neat. So what we want to do is take the loose end of our shock cord and insert it through the slot in the back of the bulkhead. And this, like the motor mount assembly, can be a little bit tricky, but I recommend you work on getting it all the way through by pushing it through. It's not too hard if it's in pristine shape. You're always welcome to cut this again, because it is a little hard to reach all the way down there to pinch it through like you did on the motor mount. But if you've got a couple inches passed through there, you're going to be able to work it. So that's passing through from the aft end into the middle. And really all you need to do now is tie a pair of overhand knots near the end of the rope, because you want this to not pull back through. Now this knot is going to prevent this from pulling back through the other way. So you can pull it in so that it sucks in through the front of the tube and mounts snugly against the back. So that's going to be a good secure mount to keep your two body parts together. Okay, some of the final assembly steps are really all that remains. The main thing we're going to do is we're going to drill the holes to secure the nose cone to the payload bay. Now, we're doing all of this after all the epoxy is dry, so I'm comfortable putting my shock cord into the airframe tube to get it out of my way, and sliding the payload bay into the airframe. Then we're going to slide our nose cone onto the forward end of the payload bay. Snug it all the way up. And what we want to do is we're drilling holes for these little plastic rivets. We want a 5/32 hole. I like to make sure I look back and I align them with my fins. So right now it's basically every time I'm drilling one, it's going to be right on top. We want to go about 1 inch back. If you want to be really picky about it, you can wrap tape around here to get your measurement right. I like to just eyeball it in this case, going just about a 1 inch back, anywhere between 1 and 3 inches, which is where your coupler is. You're going to drill a hole through both the nose cone coupler and the airframe tube. Ultimately, we're going to harden each of these holes, but the first thing I'm going to do is I'm going to insert this. Now you can separate these rivets to the anchor piece and the pin. You just at least want that anchor piece in there so that you can drill the other holes and not move anything. So right now this is now anchored in place. Even though I don't have it fully secured, it's going to hold that nose cone on for the time that I need. And I come around here and drill another one, getting it even with my other. I'm just eyeballing it, but you can measure it if you need to. And again, it'll be tighter all around. You don't need to separate them to insert them. They will fit pretty well if you just slide them in. So now with all three of those holes drilled, I don't need to be quite so worried about the precision of what I'm working here. But I'm going to make sure to remove them all now, and I want to harden my cardboard so that these are nice and strong. But I don't want to do that with my cardboard connected. It's also good to take a little bit of sandpaper, either before or after hardening, and make sure your holes are clear. So on the coupler tube, we're going to harden. And basically, you see this a little better than you have on the airframe tube. I'm putting just a couple of drips there to let it soak in around that hole, and that's going to create a very hardened framework once it's dry. So we can set that aside for now. It's okay if you're scuffing up the airframe. It's going to be covered by a decal. But in this case, I would sand the inside of the tube as well, and then you harden it and all of the other the other two anchor points. So I'm going to go ahead and harden all three in time. Okay, now we just have some steps to make sure we're keeping track of things that are easy to get lost. And one of the things to work on is attaching your motor retainer clips. Make sure that they are screwed into those holes. Now that your epoxy is dry, you don't have any risk of getting these glued in too much. And you can go finger tight. If you need to go a little bit more just to make sure it stays in place, go ahead and pull out your screwdriver and tighten that down however you need to. With those two attached, the main thing you have to keep track of is your rail buttons and screws. Best advice is to finish your rocket however you're going to finish it, paint it, apply the decals, and then once you're done, come back and dig in here with an X-Acto knife, clear out your holes, and then again anchor your rail button nuts with a drop of thick CA glue into that hole, and then drive that in with the screw. But that's going to have to wait till after you're finished. So tying the parachute on is going to start with giving it a place to live on the shock cord. Many people like to not tie a knot in the shock cord because it does create a point of weakness. While true, this shock cord is quite sturdy for the kind of weight this rocket is likely to be flying. I'm happy tying a single knot in it. And what we want to do is take a loop, usually within about a foot of the payload bay, and simply take that loop and tie a single overhand knot in both sides of the loop. So what you're left with is a loop. You can tighten down the tails. Then take all of your shroud lines from your parachute as one. In this case there are 8 lines on this parachute. Slide them through that loop. Now this is going to wind up tying a slip knot. This is very easy to remove if you need to. Take your parachute. I haven't even unbundled it yet. Keep it this nice and simple and neat, and slide it down. Grab the whole parachute and pull it tight so that it is pulling all the lines more or less at once. And that's it.